Okay, polynomials, operations of polynomials, remainder theorem, factor theorem. That's what this whole PowerPoint is based on, right? And it's important for you to know your syllabus objectives, to know exactly what you have to learn for your exam. The first thing they want you to do is to know how to perform operations of addition, subtraction, multiplication, and division of polynomials and rational expressions. Factorize polynomial expressions of degree less than or equal to 4, leading to linear factors. Determine the remainder when a polynomial is divided by a linear expression. That's called remainder theorem, and we'll look at that just now. Use the factor theorem to find factors and evaluate unknown coefficients using the factor theorem. Well, first we need to know what exactly is a polynomial. Well, a polynomial is a multi-term expression, and it's of the form ax to the power of n plus bx to the power of n minus 1 plus cx to the power of n minus 2 plus so on and so forth until you get the power to be 0. Hold on. So this is something you need to note. The power for polynomials, it must be a natural number. So what exactly do I mean by a natural number? Well, it's the number starting from 1, going all the way up. So it's 1, 2, 3, ... So it starts from 1, it goes all the way to infinity, right? That's a natural number. That's the set of natural numbers. And the power for polynomial, so you see this right here, power, right? The power must be a natural number, right? So just remember that. I have some examples here to show you. So say I have 2x squared plus x plus 1. Let me write this out. So 2x squared, 2x squared plus, according to this, my next power, I just have to minus 1 from this original power, right? So what does that mean? They told me this, basis of x. So if I just minus 1 from 2, I'll get back 1, right? And then if I minus 1 from this, I get 0. So what I'm trying to show you is how they ended up with this power. They said 2 minus 1, just like you see here. We know if we see a constant by itself, when we are doing indices, that means that the power is 0. How did they get 0? Well, they said 1 minus 1 is going to give me 0. I mean, well, you could say it like that, but let me show you how I have it. 2 minus 2 is equal to 0. That's how they got this power, right? That's how they got the power to be 0. I just wanted to show you that. If you look at the second one, 5x to the power of 4 plus 3x cubed minus 9x squared plus 2x minus 5. How did they get the power of 3? Well, they said, so according to this form, according to this form, the form of a polynomial expression, what I have to do to get this power is say 4 minus 1. That's how I got 3. To get this power, I have to say 4 minus 2. That's how I got 2, and so on and so forth, right? So the next one will be n minus 3, and then n minus 4, all the way until you get the power to be 0. This third one, remember the power must always be a natural number. A half is not a natural number. Natural numbers, it goes from 1, hold on. Natural numbers, it goes from 1 to infinity. A half is not in that set. A half is not a natural number, therefore it cannot be a power, and this is not a polynomial. Everybody good so far?
Yes, miss.
Yes, miss.
Well, addition and subtraction are polynomial expressions. So just in case you wanna know where we are now, that's this first one, right? Operations of polynomial expressions. So addition, subtraction, multiplication, and division. This is addition and subtraction. So what I need you to recall is that in algebra, like terms, only like terms can be added and subtracted. But what exactly are these like terms? Well, like terms have the same base and the same power. What do I mean by same base and same power? Well, when we were doing indices, for example, when we were doing indices, hold on. No. Okay. When we are doing indices, hold on, people are joining. When we are doing indices, we said this is the base. So x in this case would be the base, and then n is my power. So like terms in algebra have the same base.
Afternoon, Reese.
Good afternoon. Hold on, people joining. Like terms have the same base and they have the same power. This is my base, so I'll represent this as x, and the power is n. Like terms, same base, same power. So to add, oh gosh, wait, more people join in. Give me a second. All right. To add or subtract polynomials, you simply have to add or subtract the like terms. Oh my gosh. For example, if you're given this function, p of x is equal to 2x cubed plus 4x squared plus 2x plus 1, and then you're also given another function, q of x, which is 2x cubed minus x squared plus 3x plus 4. If they ask you to find p of x plus q of x, so that's just adding two polynomials, right? P of x is a polynomial, q of x is a polynomial, and they want you to add them. So all you have to do is to add the like terms, just like you were doing algebra, right? Because this is algebra. Right, so this is the polynomial p of x. This is the polynomial q of x. All I have to do, add the like terms. Like terms have the same base, which is x, and same power, which is n. So the first one, I see x cubed. So x is, well, 2x cubed. X is my base, 3 is my power. So now I look at the other polynomial, and I need to determine which one has the same base and same power, right? So this one right here, x is the base, 3 is the power. What does that mean? These two are like terms. And because they are like terms, I can add them together. 2x cubed plus 2x cubed is 4x cubed. That's just algebra, right? We already know how to do that. Like your whole math life, that's all you do. Algebra. Well, that's mostly what you do in algebra. I didn't like this. So I know, okay, it's 4x cubed. Looking at the second one, 4x squared. My base is x, my power is 2. So I look at the other polynomial and I determine which one is the like term. Well, I see the base is x, power is 2. These two are like terms, and therefore I can add them or subtract them if I need to. 4x squared minus x squared is 3x squared. Move on to the next one. 2x plus 3x is 5x, and then 1 plus 4 is 5. Everybody good so far?
Yes, miss.
If you're not good, let me know. That was just algebra that we were doing. Similarly, if they ask you to find p of x minus q of x, you subtract the like terms. Like terms have the same base, same power. So this and this, they are like terms, so I can subtract them. 2x squared minus 2x squared is 0. right? But you don't need to write the zeros. Understood, okay? 4x squared minus x squared. These are like terms, therefore I can subtract them. If I do that, 4x squared minus x squared, I would get, oh, it's minus minus. Ooh. A minus and a minus is a plus, so this is actually 4x squared plus x squared, which is 5x squared. 2x minus 3x, that would give me minus x, and then 1 minus 4 is minus 3. Everybody good so far? This is just algebra, nothing new. You good?
Yes, miss.
Yes, miss.
Okay. So that's why I only have one example for this, because it's, basic algebra, what you're doing for your whole math life, basically. So just try these for me. Add these two polynomials and then subtract them. It shouldn't take long, so I'll give you 3 minutes to do that, and then I'll go through it with you. Good. All right, could anybody tell me what answer they got for this? For f of x plus g of x. Going once. Going twice. Nobody got an answer for f of x plus g of x?
Miss, I got 2x to the power of 4 plus x cubed plus 6x minus 3.
Plus 6x minus 3. Okay, well, let me see. So addition or subtraction of polynomials, you could only do that with like terms. Like terms, they have the same base, same power. So f of x, the first term I see is this, right? 2x to the power of 4. So I look at my other polynomial. None of these terms here are like terms. I mean, compared to this, right? I don't see one with x to the power of 4. So what does that mean? I can't add anything to that term, right? So it just remains the 2x to the power of 4. I see x cubed, but there's no like term, right? So this just remains x cubed. Because there's no other like term, I can't add or subtract any other term from this or to that. 2x squared. Well, I see that this right here, that's a like term. So 2x squared minus 2x squared, that's 0. So if you want to, you could write 0x squared. Not necessary, but let me just write it down. X plus 5x, those two are like terms. So I could say x plus 5x is 6x. And then minus 1 minus 2, that's minus 3. So I can rewrite this leaving out the 0x squared because it's understood, right? This becomes 2x to the power of 4 plus x cubed plus 6x minus 3. And that is why this here is correct. Everybody good with this?
Yes, miss.
Yes, miss. I got the answer.
Okay, nice. Can anybody tell me what they got for f of x minus g of x?
Wait, miss, I'm not finished.
Yeah, it's finished. Anybody finished with it?
Miss, I got
It.
You got what?
2x to the power of 4 minus x cubed plus 4x plus 1.
Plus 4x plus 1. Okay, well, let's see if this is right. So what they want you to find, f of x minus g of x. So let me actually write for this one. So that's equal to f of x, which is this polynomial expression, 2x to the power of 4 plus 2x squared plus x minus 1. And then they told me they want this. Let me just continue. Okay. It might get confusing if I continue in another line. So me. So this is f of x, right? We're doing f of x minus g of x plus 2x squared plus x minus 1. I'll put this in brackets so I don't mess it up, right? And this is minus g of x. And g of x is x cubed minus 2x squared plus 5x minus 2. So, like I said, this is just basic algebra, what you're always doing. So 2x to the power of 4, I don't see any other like term here, so I can't add or subtract anything from or to that, right? So it just remains 2x to the power of 4. Wait, I'm missing something. Okay. I don't think it's 2x squared minus, right? So that becomes plus. That's 2x squared plus 2x squared, which is 4x squared. If you need me to slow down, just tell me, right? I'm just going a little fast because I know algebra is something you're always doing. So this shouldn't be too difficult. X minus 5x, that's my thing. X minus 5x, that's minus 4x. Minus 1 minus 2. So that's minus 1 plus 2 plus 1. So what happened here? Where's the how'd you get this?
Miss, I now realize my mistake. I left out something.
Oh, okay. Everybody go to this?
Yes, miss.
Yes, no. If I went too fast, let me know, right? So you good? I can clear this off?
Yes.
Okay.
Yes, yes.
Wait, what you said?
No, I say yes.
No, somebody else was saying something. Okay, well, we'll clear this off, right? So that's addition and subtraction of polynomials. It's just algebra, right? This as well, it's just algebra. What you're doing repeatedly over the whole course of your math life. Multiplication of polynomials is done using the distributive law, but this is nothing new because you do this all the time. Maybe it's more terms than usual, but it's the same concept, right? So p of x, that's our function, which is 3x cubed plus 2x minus 1. And then we also given q of x, which is 2x squared minus x plus 6. And I said to find p of x multiplied by q of x, what you use is the distributive law. But this is nothing new, because let me show you an example. Let me show you why this is nothing new. If you were given x plus 2 and then x minus 1, how would you expand these brackets? Anybody?
You will multiply like the x times the other x, and then the x times the -1, and then do the same thing for the 2.
That is called the distributive law, and it's the same concept you're using when multiplying polynomials. So if I had to expand these brackets here, I would say, so x by x, that's x squared. X times -1, that's minus x. 2 times x, that's plus 2x. And then 2 times -1 is -2. But of course, I know these two are like terms. So I end up with plus x minus 2. Same thing you're doing here. Same concept. It's just more terms that you're using, right? Okay, so it's, oh gosh, wait, somebody else trying to join again. Okay, now nobody else trying to join. Right. So just like we were doing just now, distributive law, it's this first term multiplied by everything in the bracket here. So 3x cubed times 2x squared, then I'll multiply 3x cubed by minus x, and I'll multiply 3x cubed by 6. Then I'll do the same thing with the 2. 2 by 2x, 2x by 2x squared, 2x by minus x, 2x by 6. Then I'll do the same thing with 1. Well, minus 1. Minus 1 times 2x squared, minus 1 times minus x, minus 1 plus 6. Same concept, just a little more terms, right? Don't get scared. It's the same thing you're doing. Same distributive law that you're applying. It's just small terms. So that's what I did here. And then when you expand these brackets, the polynomial that you will get is 6x to the power 5 minus 3x to the power 4 plus 22x cubed minus 4x squared plus 13x minus 6. Same distributive law you're using, nothing new. It's just 3 terms instead of 2 terms. I don't have an example for that because, that's what you do. It's the same concept. Division of polynomials. This is something that is new. Not necessarily the long division, but dividing polynomials. It's what would be new. So how exactly do we divide polynomials? Well, you use long division. For example, if I said, okay, before we go into the polynomials, let's recap how exactly you do long division, because that might be a problem if you don't remember how to do it. So primary school thing, right? Long division, primary school thing. Now we don't need to do long division. We could just pull out the calculator and handle everything. But nope, for this topic you need to resurrect your primary school knowledge. Okay, so let's recap how to do long division. Why is this thing giving me trouble? Hold on. Okay. So say I wanted you to divide 1,311 by 2 using long division. Well, what you would say, from primary school and all that, before you knew about the calculator, 2 into 13. Well, you say 2 into 1, you can't do that. Then you would say 2 into 13. 2 into 13 is 6, because 6 times 2 is 12. Oh gosh, well, the line wouldn't go that long. So this primary school thing, right? 13 minus 12, that's 1. You bring down the 1. Then you say 2 into 11, what's that? That's 5. 5 times 2 is 10. So that's minus 10. 11 minus 10 is 1. You bring down the last one, you put it in. 2 into 11, also 5, because we just did that. 5 times 2 is 10, so that's minus 10. 11 minus 10 is 1. So when you were in primary school, what you would say, all right, this here is called my quotient. I-E-N-T. And then this here is my remainder. So if they ask me, okay, 1,311 divided by 2, what's the quotient? The quotient is 655. And what's the remainder? The remainder is 1. Primary school thing. Everybody remembers how to do this?
Yes.
Yes, Reese.
Anybody does not remember how to do this? All right. Well, it's the same thing for polynomials. Let's try, okay. Say they wanted me to divide this polynomial here. So 2x cubed minus 3x squared plus 4x minus 8 divided by x minus 1. Let me actually, just a recap, this here is called the divisor. This is called the dividend. We just talk about quotient and remainder, right? So let me actually do this one with you because I think it's just better to do it that way.
Wait, can you zoom it in more?
Sure. Oh gosh, how do you do that?
I don't
Good.
know. Yes, Reese.
Okay, well, I'm gonna do it on the board now. So yeah. I think it's best if you actually see me do it in person with you. So you can ask any questions about it. Okay, so they gave us this polynomial expression. So it's 2x cubed minus 3x squared plus 4x minus 8. And they told you to divide this by x plus 1. And they want you to find the quotient and to find the remainder. How exactly do we do that? Well, same idea, same concept, right, of long division. So you say x into 2x cubed, that's 2x squared. So remember when we are doing indices, right? So 2x cubed divided by x squared. We said when we have the same base, we subtract the powers. And that's how I got the 2x squared, because 3 minus 1, which is the power of x, right? So 3 minus 1 is 2. That's how I got the 2x squared, right? Just to clear this up in case anybody was wondering. So like I said, we do a long division like we did just now. X into 2x cubed is 2x squared. 2x squared multiplied by x is 2x cubed. I remember we always subtracted, right? However, unlike the example that I just showed you, this one has two terms. It has x and it also has 1. So I also have to say 2x squared multiplied by 1 is going to give me 2x squared. Remember, you're subtracting them, right? You're always subtracting. So 2x cubed minus 2x cubed, that's 0. So if you want to, you can put the 0, but remember it's understood. You don't have to put. Then minus 3x squared minus 2x squared. So that would give me minus 5x squared. Let me just put this minus sign in red. Remember, we're always subtracting them, right? Just like we were doing with the long division just now. Then you bring down this other 2. So you get plus for x. Then you start again. X into minus 5x squared, that's going to give me minus 5x. Then minus 5x multiplied by x, that's minus 5x squared. But remember, I have two terms in my divisor, so I also have to say minus 5x multiplied by 1, which is going to give me positive 5x. Remember, you're always subtracting them, just like we were doing just now. So what does this become? Well, minus 5x minus 5x squared. So remember, minus and a minus is going to give me a plus. So what does this really mean? It means 5x squared minus 5x squared plus 5x squared, which is going to give me 0. Remember, you don't have to write it, it's understood. Then 4x minus 5x is going to give me minus x. Just like we were doing before, you bring down the next term. The next term is minus 8. You do the same process again. X into minus x, that's going to give me minus 1. Minus 1 multiplied by x, minus x. Remember, I have two terms, so I also have to say minus 1 multiplied by 1 is minus 1. Remember, we are always subtracting them, just like we were doing just now. What does this give me? Well, minus x minus minus x. So minus and a minus is a plus. So that's minus x plus x, which is 0. And then minus 8 minus minus 1. That's the same as saying minus 8 plus 1, which is minus 7. Wait, did I do that right? Because I have a different answer here. Pain. Okay, everybody understand?
Yes, please.
Oh, I see. Hold on. I made a little boo-boo. This is supposed to be minus 5. So it's minus 5 times 1 is minus 5, not plus 5. So what is this really? This is 9x. 4 minus minus 5x, that's the same as saying 4 plus 5x. Well, 4x plus 5x, which is 9x. Bring down the minus 8. X into 9x is 9. That's plus 9. 9 multiplied by x, 9x. 9 multiplied by 1, 9. Remember, we are always subtracting them. So my answer is minus 8 minus 9 minus 17. They asked me for the quotient and for the remainder. So this right here, this is my quotient. So just put QU. And this is my remainder. Everybody good?
Yeah.
Following?
Yes.
So nothing too difficult, right? That's what I have here. Same concept doing. Now it's time for you to practice. Oh gosh, I have less than a minute. Okay.